We build machines that can create ocean waves hundreds of miles from the sea. Ships can generate them without even trying. And engineers can reproduce tsunamis inside laboratories. But once enough water starts moving, the difference between a controlled wave and a disaster can disappear very quickly. From programmable surf waves to massive surges that damaged structures, swept through crowds, and devastated entire communities. These are 10 artificial waves, powerful enough to cause chaos. Number 10. Number 10. The Wave Palace, Tenerife. It looks like a tropical swimming lagoon. Then, a nearly 10-foot wall of water rises from one end of it. The Wave Palace is located inside Siam Park on Tenerife, in Spain's Canary Islands, and it is one of the largest artificial wave pools built for a water park. The lagoon covers more than 13,000 square meters, but the feature that makes it unusual is hidden behind the far end of the pool. A mechanical wave generation system can push a large volume of water forward at once, producing waves that can reach roughly 3 meters in height. That is large enough for actual surfing. And creating a wave like this is very different from simply moving water around a swimming pool. In the ocean, wind transfers energy into the surface over enormous distances. Here, the same basic result has to be created mechanically, inside a confined space and within only a few seconds. The system releases water in a controlled sequence. The surface begins to rise. The moving mass of water travels across the lagoon, becomes steeper as it approaches the artificial beach, and eventually breaks like a natural wave. But the size of the wave is only part of the engineering problem. It also has to break in roughly the same place each time. That allows the park to control where swimmers experience the strongest part of the wave, and also makes dedicated surfing sessions possible. During normal operation, the entire event is carefully controlled. The machinery determines when the wave begins, how much water is moved, and how the resulting surge travels through the pool. That level of control is what separates modern wave pools from the much simpler designs used decades ago. Instead of creating random turbulence, engineers can now shape the movement of the water itself. And once several thousand tons of water are moving in the same direction, the result can look surprisingly close to something produced by the ocean. The Wave Palace was designed as entertainment, but the same basic idea, using machinery to move enormous volumes of water in a controlled way, can be taken much further. Because some artificial wave systems are not designed for crowded beaches at all. They are built to recreate the kind of water movement engineers normally only see during disasters. Number 9. Kelly Slater's Surf Ranch. More than 100 miles from the Pacific Ocean, a 6-foot wave travels across a farm field in Central California. And it can do it again, almost exactly the same way. This is Kelly Slater's Surf Ranch, located near Lemoore, California. At first glance, the facility looks less like a surf destination and more like an enormous, narrow lake surrounded by agricultural land. But running along that basin is a machine designed to manufacture something surfers normally have to wait hours, days, or even weeks to find: a nearly perfect breaking wave. The main wave can travel more than 2,300 feet, roughly 700 meters across the basin, producing rides that can last close to a minute. And unlike an ocean swell, its behavior can be controlled. The system can change the wave profile for different levels of surfers, from relatively forgiving waves to fast, competition-level barrels used by some of the best surfers in the world. But the unusual part is how that wave is created. Instead of relying on wind or distant storms, the Surf Ranch uses a massive mechanical system that moves through the water. A specially designed hydrofoil generator transfers energy into the basin, pushing the water into a moving swell. The shape of the bottom then helps that swell rise and break in a controlled pattern. Kelly Slater Wave Company says the technology can produce wave faces reaching up to 8 feet while maintaining their size and energy through the ride. Creating that consistency took years. The project began with formal research into shallow water waves and eventually moved to small-scale experiments. By 2009, the team had constructed a 1 to 15 scale model, producing waves only about 4 inches high. 6 years later, the full-size prototype was producing barreling waves around 8 feet high. When footage of Kelly Slater riding the finished wave appeared in December 2015, it immediately attracted attention across the surfing world. For one simple reason. Ocean waves are unpredictable. This one wasn't. Its starting time could be controlled. Its direction could be changed. Its shape could be adjusted. And once the machine began moving, hundreds of meters of previously calm water became a breaking surf line. That level of control eventually made the facility suitable for World Surf League competition, with the wave officially used for elite surfing events. But Surf Ranch is still a controlled machine, operating inside a carefully engineered basin. The waves coming next are different. Because once enough water begins moving outside that kind of controlled environment, the people nearby don't always get to choose when it arrives. Number 8. Lost Shore Surf Resort. In Scotland, an abandoned quarry was turned into something that should not exist this far from the ocean. A machine that can manufacture up to 1,000 waves every hour. Lost Shore Surf Resort sits near Edinburgh, about 15 kilometers from the city, and contains what its operator describes as Europe's largest wave pool. The lagoon uses a 52-module Wave Garden Cove system, capable of producing more than 20 different types of waves, ranging from roughly half a meter to 2 meters high. But the unusual part is not simply the height, it is the frequency. At maximum output, the system can generate up to 1,000 waves in a single hour. That works out to a new artificial wave roughly every 4 seconds. And unlike the long mechanical wave at Surf Ranch, these waves can be altered almost instantly. The system uses a series of mechanical paddles powered by electric motors. Each paddle moves the water in a carefully controlled sequence, creating disturbances that combine inside the lagoon and begin behaving like an ocean swell. By changing the timing and movement of those paddles, operators can alter the size, shape, speed, and difficulty of the resulting waves. One setting can produce relatively gentle waves for beginners. Another can create fast breaking sections and barrels for experienced surfers. And one of the most powerful configurations is known as the Big Beast. Wavegarden describes it as the heaviest wave in its menu, reaching around 2 meters high and reserved for expert surfers. But there is another reason the system is so different from traditional wave pools. It does not have to create the same wave over and over again. The wave itself is effectively programmable. The same body of water can behave like several different surf breaks, simply because the machinery behind it receives different instructions. Lost Shore can accommodate more than 90 surfers at once, while the 52-module system can continue generating waves across different sections of the lagoon. That turns what looks like a single artificial lake into something closer to a mechanically controlled coastline. And the scale becomes even stranger when you look at where it was built. There was no natural surf break here. The site was a former quarry. The ocean had to be recreated from scratch. At Lost Shore, every important part of the wave, when it begins, how large it becomes, where it breaks, and what kind of ride it creates, can be controlled by machinery. But all of that still happens inside a basin specifically designed to contain the energy. The next kind of artificial wave does not always have that advantage. Because sometimes the machine creating the wave is not sitting beside a swimming lagoon. It weighs tens of thousands of tons and is moving through open water. Number 7. Cargo ship waves on Vietnam's Long Thao River. There is no wave machine on Vietnam's Long Thao River. The ships are the wave machines. This waterway, southeast of Ho Chi Minh City, is an important shipping route used by enormous cargo vessels traveling between the city and the sea. And every time one of those ships moves through the narrow channel, it has to push an enormous amount of water out of its way. The result can be surprisingly large waves. In 2026, footage from the river showed vessels including the 639-foot-long Ever Oath generating long, clean wakes that rolled away from the ship and began breaking along the riverbanks. Another vessel, the 623-foot Hua Heng 167, was filmed producing displacement waves that traveled for hundreds of yards through the river. But these are not ordinary ripples behind a boat. The physics begins with displacement. A cargo ship weighing thousands of tons occupies space that was previously filled with water. As the hull moves forward, that water has to move somewhere. Some is pushed outward, some moves around the hull, and some of that energy leaves the ship as a spreading pattern of waves. In deep, open water, those wakes have plenty of room to disperse. The Long Thao River is different. The channel is relatively confined, the shoreline is much closer, and sections of shallower water can cause the wake to change shape as it travels. A wave that begins as a broad disturbance behind the ship can become steeper as it approaches the bank. In several recorded examples, those waves become organized enough to resemble small ocean surf. Some even form brief barrels. That has attracted attention from surfers, but the same feature that makes these waves interesting also makes them dangerous. This is still an active commercial shipping channel. There are strong currents, large vessels, smaller fishing boats, and limited room to maneuver. Footage from the river has also shown smaller boats being hit hard by wakes produced by passing cargo ships. And that reveals the biggest difference between this and the artificial waves we've seen so far. At a surf park, engineers decide when the wave starts. They control its size. They control where it breaks. And everyone in the water knows why it is there. On the Long Thao River, the wave is simply a side effect of moving a massive object through a confined body of water. Nobody built it for surfing. Nobody designed the riverbank to absorb it. The ship only has to keep moving. The water does the rest. And cargo ships are not the only vessels capable of turning engine power and displacement into unexpectedly destructive water. Because the next example shows what can happen when an enormous passenger ship moves the water around it in exactly the wrong place. Number 6. The Norwegian Star Wake Incident. On the morning of July 8, 2012, a cruise ship was maneuvering into a pier on the Hudson River in New York City. It never struck the museum beside it, but the water it moved did. The ship was the Norwegian Star, a large passenger vessel attempting to dock at Manhattan's Pier 88, just north of the Intrepid Sea, Air and Space Museum. Strong currents in the Hudson made the maneuver more difficult than usual. To hold the ship in position, the crew had to use additional propulsion and its maneuvering thrusters. Those engines pushed huge volumes of water away from the hull, and that created a larger-than-normal wake. A short distance away, the retired submarine USS Growler was moored as part of the Intrepid Museum. The waves reached the submarine and began rocking it against the water. Then, something gave way. A gangway connecting visitors to the Growler was damaged and fell into the Hudson River. At first, reports even suggested that the cruise ship itself might have collided with the museum. It had not.
The Norwegian Star remained at the nearby passenger terminal. The damage had been caused entirely by the movement of the water. That is what makes this incident unusual. A cruise ship does not need to be traveling at high speed to create a powerful artificial wave. During docking, thrusters are used to move a vessel sideways or help keep thousands of tons of ship precisely positioned against wind and current. When enough thrust is applied, the water, accelerated by those systems, has to go somewhere. In this case, it spread across the Hudson and reached another vessel nearby. The Coast Guard said the Norwegian Star's maneuvering procedures were normal. Strong currents simply required more propulsion than usual. There were no reported injuries, and the Growler was able to reopen to visitors later that day. But the incident demonstrated something important. The engines were designed to move a ship. The wave was only a byproduct. And yet, that byproduct was powerful enough to move a retired submarine and knock its gangway into the river. So far, every artificial wave in this countdown has been created by moving water mechanically. But engineers can also do something far more extreme. They can deliberately release an enormous mass of water all at once, specifically to reproduce one of the most destructive waves on Earth.
Number 5. Europe's Giant Tsunami Simulator. Inside a laboratory in England, engineers deliberately create tsunamis, not with computer graphics, with 70,000 litres of real water. The machine is located at H.R. Wallingford in Oxfordshire, inside a 75-metre-long channel known as the Fast Flow Facility. It is the largest specialist tsunami simulator in Europe. Unlike an ordinary wave machine, this system is designed to reproduce what happens when a tsunami approaches land. A normal ocean wave passes quickly. A tsunami is different. Its wavelength can be enormous, and when it reaches shallow water, a huge mass of water can continue moving inland for minutes. The simulator uses a sealed tank at one end of the channel. A pneumatic system lowers the pressure inside, drawing water upward into the chamber. That first movement can reproduce one of the strangest warning signs of a real tsunami: the sea suddenly retreating from the coast. Then air is allowed back into the tank. The stored water drops and rushes into the channel, creating an artificial tsunami. Researchers place model buildings, seawalls, and coastal defenses directly in its path to see how they respond. At a scale of 1 to 50, the simulator can reproduce different tsunami patterns, including traces based on real events such as the 2004 Indian Ocean tsunami. It can also reproduce duration. A real tsunami, lasting around 20 minutes, can be reduced to almost 3 minutes inside the laboratory. And that is important because a tsunami does not simply hit once and disappear. The water keeps moving. It flows around buildings, overtops defenses, and fills streets. Some experiments have even shown that structures designed to stop flooding can sometimes make conditions worse by trapping and suddenly releasing water. These tests are helping engineers better understand the forces acting on coastal buildings and sea defenses. So this machine is not creating chaos for spectacle. It creates controlled disasters so researchers can learn what fails before a real tsunami arrives. And the next facility takes that idea even further. Number 4. Germany's GWK plus artificial tsunami. In Hanover, Germany, scientists can send a tsunami through a 300-meter-long channel, and for much of that distance, you may barely see it coming. The facility is called GWK+, the Large Wave Flume, operated by the Coastal Research Center of TU Braunschweig and Leibniz University, Hanover. It is 300 meters long, 5 meters wide,
and its wave machine can produce waves up to 3 meters high. But these experiments are not about making the tallest possible wave. They are about reproducing how a real tsunami moves. Researchers generate long waves that travel through the channel, climb an artificial slope, steepen, break, and then continue across a flat platform representing the coastal plain. And the experiment does not stop at the shoreline. That is where the real test begins. Scientists place structural components directly in the path of the water. In one experiment, a steel frame covered with aluminium panels was built at roughly 1/5 scale. When the artificial tsunami reached it, the structure moved about 15 to 20 centimeters under the force of the water. Then researchers added debris. Colored wooden blocks were released into the flow to represent wreckage carried through a flooded city. Now the structure was not only being pushed by water, it was also being struck by moving objects. Eventually, the test column toppled. And that reveals one of the most dangerous things about a tsunami. The water itself is only part of the threat. As it moves through populated areas, it can carry timber, vehicles, containers, and pieces of buildings, turning them into powerful impact loads. Researchers have also found that large amounts of debris can change how long-period waves behave. That information can improve tsunami hazard models and help engineers design safer coastal structures. The huge scale of GWK+ allows some experiments to be performed much closer to real-world conditions, and the facility is becoming even more powerful. A planned dam breach generator will hold water up to 3 meters deep behind a movable gate before suddenly releasing it as a massive surge. So scientists here are not simply making waves. They are recreating the chain of destruction, the flooding, the debris, and finally, structural failure. But everything here still happens for research. The next wave was different. It was not created to study a disaster. It became the disaster.
Number 3. The Vajont Megawave. On October 9, 1963, one of the tallest dams in the world survived a disaster almost exactly as it had been engineered to. The town below it did not. The Vajont Dam stood more than 260 meters high in a narrow valley in northern Italy. But the greatest danger was not the dam. It was the mountain beside the reservoir. For years, the northern slope of Monte Toc had shown signs of instability. Then, at 10:39 that night, an enormous section of the mountain broke loose. Roughly 270 million cubic meters of rock plunged into the reservoir in only about 20 to 25 seconds. There was nowhere for the water to go. The landslide displaced it almost instantly, throwing around 50 million cubic meters of water into motion. A gigantic wave surged across the valley, climbed hundreds of meters up the opposite slope, and then turned toward the dam. And this is where Vajont became almost unbelievable. The wave rose high enough to pass over a dam more than 260 meters tall. The dam itself remained largely intact. The water simply went over it. It crashed into the narrow gorge below and rushed toward the Piave Valley. Longarone stood directly in its path. Within minutes, much of the town and surrounding settlements had been destroyed. Italy's Civil Protection Department records 1,917 deaths. That is what made Vajont different from an ordinary dam failure. The concrete structure did not collapse. Instead, the reservoir itself became the weapon. A mountain entered the lake so quickly that the displaced water behaved like a gigantic impact wave. And there had already been warnings. A smaller landslide had entered the reservoir in 1960. Engineers monitored the slope, adjusted water levels, and even conducted hydraulic model tests. But the final collapse was far larger and faster than the scenario they had prepared for. Perhaps the most disturbing detail was what remained afterward. The dam was still standing. From an engineering perspective, the structure survived. For the communities downstream, that meant almost nothing. Vaillant became one of history's clearest examples of how human engineering can transform a geological event into something vastly more destructive. Nobody switched on a wave machine. Nobody intended to create a tsunami. Human engineering built the reservoir. Gravity supplied the trigger. And within seconds, an entire mountainside turned that stored water into a wave powerful enough to cross one of the tallest dams on Earth. But the next artificial wave needed something much smaller. A machine malfunction, a crowded pool, and only seconds for everything to go wrong. Number 2. The Yulong Shuiyun Wave Pool Malfunction. On July 29, 2019, hundreds of visitors were relaxing inside a wave pool in northeastern China. Then the machine produced a wave it was never supposed to make. The accident happened at Yulong Shuiyun Water Amusement Park in Longjing, Jilin Province. At around 2:40 in the afternoon, swimmers were floating across the pool when the surface suddenly began to rise. Within seconds, a huge wall of water formed at the deep end. Video from the scene shows people noticing the danger only moments before it reached them. Some tried to swim away, others remained on inflatable tubes. Then the wave broke. People were lifted, thrown into one another, and carried toward the shallow end. Some were pushed completely out of the pool and onto the surrounding pavement. 44 people were injured. Most injuries were minor, but several visitors required hospital treatment. No deaths were reported. At first, rumors claimed that an intoxicated employee had selected the wrong setting. That story was false. The preliminary investigation found a mechanical problem instead. An intermediate relay inside the electrical system controlling the wave generator had been damaged. That failure caused the pool to create waves much larger than intended. The attraction was shut down while authorities investigated, and the incident was later cited by China's State Council Work Safety Committee when calling for stronger oversight of amusement facilities. That is what makes this accident so different from the controlled wave machines earlier in the countdown. In normal wave pools, computers and machinery control exactly how much water moves. At Yulong Shuiyun, that control was suddenly lost. The water simply did what the malfunctioning system told it to do. And once that mass of water began moving toward a crowded pool, there was no way to stop it halfway. For a few seconds, a recreational attraction became something completely different. A machine designed to imitate the ocean demonstrated just how dangerous artificial waves can become when control disappears. But this was still only a swimming pool. The number 1 wave involved vastly more water, and when the structure holding it failed, there was nothing waiting to stop it. Number 1. The Maupassant Dam Break Wave. At 9:11 p.m. on December 2, 1959, a concrete dam in southern France suddenly gave way. 21 minutes later, Fréjus was being swallowed by the water it had been built to hold back. The Maupassant Dam stood about 60 meters high across the Réran River, roughly 12 kilometers upstream from the city. After days of heavy rain, the reservoir had risen close to its maximum level. Then, the dam failed. Unlike Vaillant, no mountain was needed to displace the water. This time, the barrier itself disappeared. Roughly 50 million cubic meters of water were suddenly released into the narrow valley. The initial flood wave has been estimated at around 40 meters high, roughly the height of a 12-story building, but the valley made the disaster even worse. Steep slopes concentrated the water, and forced it downstream instead of allowing it to spread out. Roads, bridges, buildings, and electrical infrastructure were destroyed as the wave raced toward populated areas. Then it reached Fréjus. Only about 21 minutes had passed since the dam broke. By then, the flood had become a violent mixture of water, mud, rocks, and debris moving through the darkness. There was almost no time to escape. Official French records list 421 deaths, while thousands more were affected or displaced. Malpasset later became one of the most important dam break case studies in hydraulic engineering. Researchers measured high water marks, reconstructed the valley, built physical models, and later used the disaster to test computer simulations of catastrophic flooding. And the lesson was clear. When a dam fails, the danger is not simply that a reservoir empties. The stored water becomes a moving mass with enormous momentum. Terrain controls where it goes. Narrow valleys concentrate it. Debris makes it more destructive. Every kilometer downstream becomes part of the disaster. That is what separates Malpasset from every artificial wave earlier in this countdown. Some were created for entertainment, others for surfing or scientific research. Vaillant required a mountain to move the water. At Malpasset, nothing had to create the wave. The structure holding back millions of tons of water simply disappeared. Gravity took over, and within minutes, water stored for human use became one of the most destructive man-made flood waves ever recorded in France. Artificial waves can be engineered, programmed, tested, and controlled. But water does not care why it was set in motion. Whether the force comes from a machine, a ship, a landslide, or a failed dam, once enough water begins moving, the consequences can become enormous. And that may be the most important thing these waves reveal. We have become very good at controlling water, but never completely. If you enjoyed this video, subscribe for more extraordinary engineering, disasters, and real events that show what happens when human technology meets the forces of nature.